In October of 2017, something quietly entered our solar system. No explosion, no warning, no announcement, just a faint moving captured almost by accident in a routine sky survey. At first, astronomers thought it was ordinary, another small asteroid, another piece of cosmic debris. But within days, they realized they were looking at something no human had ever seen before. A visitor, not from another planet, not from another orbit, but from another star system. This was the first confirmed interstellar object ever observed passing through our solar system. And it would soon become one of the most controversial objects in modern astronomy. Its name was simple, Oumuamua, and almost everything about it was wrong. The trajectory that made no sense. The first alarm came from its path. Most objects in our solar system follow predictable orbits, ellipses, loops, repeating cycles around the sun. But this object did not. Its trajectory was hyperbolic, which means something very specific. It was not bound to the sun. It was not orbiting anything here. And once it left, it would never return. Calculations showed it was traveling at nearly 26 kilometers per second before it even encountered the sun. That speed alone was remarkable. But what shocked astronomers even more was this. The sun's gravity barely slowed it down. It didn't spiral inward. It didn't settle into orbit. It simply passed through, as if it had more than enough energy to ignore our star entirely. That alone confirmed one thing with certainty. This object was not born here. It came from interstellar space, from somewhere between the stars, the shape that defied physics. As telescopes focused on the passing object, another puzzle emerged. It was rotating, but not smoothly. Its brightness fluctuated wildly, sometimes bright, sometimes dim in a way no normal asteroid behaves. The light curve suggested something extreme, either an object at least 10 times longer than it was wide, shaped like a cosmic needle, or a thin, flat disk, tumbling through space like a drifting coin. Both shapes were unprecedented. No known asteroid, no comet, no natural object in our catalogs matched those proportions. Even stranger, the reflection of sunlight from its surface was inconsistent, not smooth, not uniform, almost as if different regions had completely different textures or materials. Metallic? Icy? Rocky? No one could tell, because there was something else missing, something that should have been obvious. The acceleration without a cause. As Oumuamua passed near the sun, scientists noticed something subtle. It was speeding up, just slightly, but measurably. This kind of acceleration is common in comets. When ice vaporizes, gas jets push the nucleus forward like a tiny rocket. But here's the problem. There was no gas, no dust, no tail, no visible plume, no chemical signature, nothing. Yet the object was clearly accelerating away from the sun, breaking the rules. And now the question changed completely. If no gas was pushing it, what was? The hypothesis that shocked the scientific world. This is where the story took a turn no one expected. In 2018, Harvard astrophysicist Loeb proposed an idea so controversial that it instantly divided the scientific community. What if the acceleration was caused not by gas, but by light itself? Photons carry momentum, and when light hits a thin surface, it can push it forward. This principle is real. We already tested with experimental spacecraft. It's called a light sail, a sheet of ultra-thin material that moves using only radiation pressure. Loeb calculated that if Oumuamua were extremely thin, extremely light, and very wide, then sunlight alone could explain the acceleration perfectly. No fuel, no gas, no exhaust, just pure photon pressure, which led to a question that instantly echoed across headlines. What if this object was not natural at all? Artifact or asteroid? Loeb never claimed it was an alien spacecraft, but he suggested something more subtle. A fragment, a relic, a piece of ancient technology drifting through the galaxy long after its creators vanished. A cosmic bottle in the ocean, perhaps a broken light sail, perhaps debris from an old probe, perhaps something abandoned millions of years ago. The idea was electrifying and terrifying, but also deeply controversial. Many astronomers pushed back. They argued that unknown natural processes could still explain the data: hydrogen outgassing too faint to detect, exotic ice compositions, porous structures, thermal effects. But every explanation required new physics or rare conditions. Oumuamua refused to fit any clean category. Not a comet, not an asteroid, not easily natural, not convincingly artificial. Just wrong. The second visitor and a clue. 2 years later, in 2019, another interstellar object arrived. Its name, 2I/Borisov. This one behaved exactly as expected. It had a coma, a tail, gas emission, typical chemistry, carbon monoxide, water vapor, hydrogen cyanide, everything familiar. And that comparison changed everything. 2 visitors from outside the solar system. One normal, one bizarre. Same kind of orbit, same hyperbolic path. But only one showed anomalies, which raised a haunting possibility. Oumuamua wasn't representative. It was exceptional. A third arrival in 2025. Then, in July 2025, something else appeared. Detected early, tracked carefully, cataloged as 3I/Atlas. This one was larger, faster, roughly 66 kilometers per second. And once again, perfectly normal. Classic comet behavior. Gas release, dust tail, predictable acceleration. 3 interstellar visitors. 2 completely natural. 1 still unexplained. The vanishing. By the time humanity realized how strange Oumuamua truly was, it was already gone, moving away from the sun at nearly 200,000 kilometers per hour. Too fast to chase, too faint to track, too distant to observe again. No spacecraft could reach it. No telescope could resolve it. It disappeared into interstellar darkness, leaving behind only 11 days of data, incomplete measurements, ambiguous models, and endless debate. What was it really? Today, there are only 2 realistic possibilities. Either Oumuamua was a completely natural object formed under rare and extreme conditions we do not yet understand, a cosmic accident, or it was not natural at all, a relic of technology, a silent fragment of engineering older than human civilization. Not a probe, not a weapon, not a message, just debris, drifting, forgotten, meaningless, but still artificial. And here is the final, unsettling truth. If an object like that passed through our solar system once, it will happen again, and again, and again. We are now building telescopes capable of detecting hundreds of such visitors. Soon, interstellar objects will no longer be rare. And one day, we may detect one that does not tumble, one that changes direction, one that emits signals, one that slows down. And then, the question will no longer be philosophical. It will be immediate, direct, and unavoidable. Because Oumuamua may not have been a message. It may have simply been the first whisper that the galaxy is not as empty as we once believed.